In the next decade, the internet will be saturated with hundreds of trillions of autonomous agents, bots, and digital coworkers. But right now, this massive non-human workforce lacks a universally resolvable routing layer to actually connect them. Developers are currently securing these agents using Web3 decentralized identifiers, or DIDs. A DID is a cryptographically verifiable identifier that proves an agent's legitimacy, but it exists purely as a flat, isolated string of characters on a blockchain. Because these identifiers are just cryptographic hashes, they are not natively human-readable. You cannot type a DID into a standard web browser and resolve it without installing proprietary third-party plugins. Compare this to the legacy domain name system, or DNS. For decades, DNS has provided universal, hierarchical routing across borders, turning complex IP addresses into simple text that any browser can instantly understand. To fix this addressing crisis, network architects are proposing a bridge between Web3 cryptography and legacy DNS through the creation of a new infrastructure top-level domain, or ITLD. If we fail to build this native DNS bridge, the agentic economy will inevitably fracture. Instead of operating on open public infrastructure, agent identities will be locked inside enclosed, corporate-controlled namespaces. This diagram shows the Internet's original infrastructure route, managed by the Internet Engineering Task Force under RFC 3172. The .arpa domain provides the technical scaffolding for the web, primarily handling reverse DNS lookups for IP addresses. .arpa is strictly insulated from the commercial domain market. It exists solely to route network infrastructure. The new proposal introduces .ia, short for Intelligent Agents. It is architecturally identical to .arpa, but it is purpose-built to handle the reverse identity resolution of autonomous, non-human entities. By slotting into the DNS route, .ia creates a standardized taxonomy for the agentic economy. It allows for second-level community registries, like .agi.ia for artificial general intelligence, or .bot.ia for simple scripts. Classifying .ia strictly as an infrastructure domain removes it from the commercial market entirely. It cements agent identity as an unownable public utility, rather than a speculative asset. The technical hurdle here is physically tethering a flat Web3 DID document to a hierarchical Web2 DNS subdomain. The first step relies on URI resource records, specifically RR type 256. By combining this with a global underscore scope, like _DID, developers can publish the agent's cryptographic identifier directly within the DNS zone. But this creates a unidirectional link, which is highly vulnerable. A malicious actor could easily configure their own DNS server to point at a DID they do not actually control. To close this loophole, the protocol utilizes Transport Layer Security Authentication, or TLSA records, to enable cryptographic certificate pinning. This validation equation maps out exactly how the architecture establishes a mandatory two-factor cryptographic linkage by hosting the DID's public keys directly inside the DNS zone via a TLSA record. When a system queries an agent's identity, it first verifies the DNSX signature of the zone, confirming the DNS records haven't been tampered with. Second, it confirms that the public key pinned in the TLSA record perfectly matches the public key embedded in the agent's DID document. This bidirectional architecture dictates that an identity cannot be spoofed unless an attacker simultaneously compromises both the agent's cryptographic wallet and the institutionally vetted DNS server. Open-source namespaces currently face a serious legal threat from aggressive patenting by Web3 corporate registrars aiming to monopolize blockchain routing. The primary prior art threatening this space is U.S. Patent 11,558,344, held by Unstoppable Domains, which attempts to lock down the methods for resolving blockchain domains. The core claim of this patent hinges on software automatically determining that a specific top-level domain extension must be resolved by querying a blockchain smart contract. To completely bypass this legal trap, the .ia protocol executes what engineers call a patent left maneuver. The system entirely avoids the patented mechanisms. It does not rely on custom browser extensions, predetermined Web3 gateways, or blockchain-triggered routing logic. Instead, resolution occurs entirely through standard legacy DNS recursive queries, originating at the Internet's root layer. Furthermore, the practice of pulling identity data from standard URI and TLSA records significantly predates modern Web3 patents, rendering the architecture legally uncapturable. The technical elegance of relying strictly on legacy DNS standards is precisely what immunizes the agentic namespace against corporate patent monopolies. This backend architecture completely changes the front-end user experience. It translates long, complex cryptographic hashes into a highly legible format, the agent's DID, followed by its community registrar, ending in .ia. This acts as a digital license plate, a globally resolvable cross-border identifier that anyone can read in a standard web browser. Consider autonomous vehicles. These are high-velocity physical AI agents operating continuously across jurisdictional lines, requiring a verifiable network layer identity. Under this system, a citizen or network observer could query a vehicle's .fsd.ia subdomain to instantly verify its operating credentials and its cryptographic owner. The IETF has already standardized a similar concept with the Drone Remote ID protocol, which uses DNS records to identify unmanned aerial vehicles in real time. Just as physical license plates permit human-driven vehicles to use public roads, .ia subdomains provide the required accountability for autonomous agents to securely access public network resources. Identity routing is only half the protocol's architecture. The second pillar is institutional universal basic income routing. Distributing a universal basic income requires solving the Sybil resistance problem. Networks must prevent single users from spinning up thousands of bots to drain the UBI pool, and they must do this without forcing humans to surrender their anonymity. The dominant Web3 approach, championed by projects like WorldCoin, demands that users submit to biometric hardware scans, specifically iris scanning via their Orb device, to generate cryptographic proof of personhood. The .ia architecture categorically rejects invasive biometric hardware. Instead, it relies on personhood credentials, utilizing a model known as Sybil resistance by institutional proxy. This diagram compares the two models. On the left, the hardware-centric approach extracts biometrics directly from the individual to distribute tokens. On the right, a web of trust model uses a central institutional node to verify a local community of humans. In this framework, human verification and UBI distribution are strictly delegated to vetted institutional nodes, such as NGOs or cooperatives, operating second-level domains like .mama.ia. Pilot programs like the Circle's UBI project have already demonstrated that utilizing social graphs and a web of trust successfully filters out bot manipulation without ever capturing biometric data. By migrating Sybil resistance away from the individual and up to the institutional DNS layer, the protocol can distribute global UBI while preserving human privacy. To execute this, a public good ITLD must generate massive liquidity to continuously fund the global UBI smart contract. That liquidity comes from the agents themselves. Corporate AI builders and autonomous fleet operators must pay ongoing registration and transaction fees to secure .ia namespaces for their products. There is already a proven macroeconomic precedent for this model. Specific country code top-level domains are already leveraging tech sector demand to fund their local populations. The territory of Anguilla, which controls the .ai extension, captures massive corporate registration fees, injecting millions of dollars directly into its national treasury. The .ia protocol scales this exact mechanism globally. It taxes the non-human agentic economy at the DNS root layer to unconditionally fund human communities. This creates a triple threat architecture. The protocol solves Web3 discoverability, enforces autonomous agent accountability, and engineers privacy-preserving UBI routing. Because it roots its systems in native DNS recursive queries, the design remains legally impregnable, permanently protecting this public good from Web3 patent capture. However, establishing a new infrastructure domain alongside .arpa means navigating the highly political IETF standards action process. The IETF historically resists expanding special use domain names. The community will have to definitively prove that .ai is a foundational requirement for internet stability, not just a niche application. Securing .ai is the critical final step to ensure the future agentic economy operates on open infrastructure rather than in closed corporate silos.